So as we know that, I think last class we stopped when we are going in the lift upward, and as well as when we are coming in the lift downwards. Am I correct, everybody? So as we know that, when we are going upside, like upwards, in the lift, so we all knows that F net is equals to, so MA. So what is the formula? We got it. Net force is equals to mg plus ma. So that is what during the lift, when we are going up, so it is appears to be, we'll feel that we'll be feeling more weight or less weight. Everybody will feel more weight. Clear? Same way, when we are coming down, when we are going down, so as we all knows that we derived the equation, normal reaction is equals to mg minus ma. So that is what, let me take m is common, so g minus a. So we'll feel less weight or more weight? Everyone will feel less weight when you keep on going down. Yes or no? We derived or not last class, everyone? No response. Yes? All of you? Okay. So now in today's class, as I told you in the last class, so be at least your 11th class, at least understand or not, or doubt or something you speak only correct, it will be good. So let me take now. So there is a lift which is attached to the rigid surface. So it has been attached to with the help of a string. So inside there is a man who is staying. So now observe very carefully. A man is inside the lift. Now lift is in somewhere, like above from the ground somewhere. Now suddenly there is a person here who cut this lift with the help of a scissor. Okay. So who cut this lift with the help of what? Everybody? With the help of scissor. So he cut this string. So what will happen by this time? It's like a class 9. If you cut this string, so what will happen? The body will be in under what? Everybody. The body will be in under free fall. Am I right or wrong? All of you? The body will be under in free fall. Yes, Mr. Rudreswa, brothers, are you there? Simply, am I teaching? Simply shouting. So when the ball is in, if anybody will cut this wire, suppose there is a person who cut this wire, so then the entire lift along with this boy is in a free fall case. So in this case, you observe very carefully. So as we know, the lift is in free fall, like entire lift I will consider as a object. So we all knows that it is in a free fall. So still the upward force is acting, that is what normal, and the downward force which is acting mg, and as well as when it is in falling down, so acceleration is also downward direction or upward direction? Acceleration also. Downward direction is downward direction. So if I consider this FBD, if I draw the free body diagram for this one, so all of you observe very carefully. So one force is acting upward direction, another force is acting downward direction now, and acceleration is also acting what direction? Downward direction. If I apply the F net is equals to, so F net is equals to what, everybody? MA. So if I apply the force, so as it acceleration is acting this one, so this is positive and this is what, everybody? This is negative. So what will happen? mg minus n, which is equals to ma. Okay. So now from that I will take n is equals to, if you observe, mg minus ma. Am I right or wrong, everybody? mg minus ma. So mg minus m, observe very carefully. When it is freely falling, a is equals to z. Am I right or wrong? All of you. A is equals to z. Acceleration.
Yes, sir.
Yes or no? So that's all. So in this case, so in place of a, I can write as a what? G only. So if I take the m common, so g minus g, which is equals to how much, everyone?
0.
So that is why when
0, sir.
So normal reaction n is equals to 0. So that is what during this case. So the net resultant, normal reaction is equals to 0. So we'll feel that we do not have any kind of weight. Either weight is decreasing or weight is increasing not. So we'll feel that we don't have any kind of weight. Clear, everybody? Weightlessness. That is what we will say, like a concept, weightlessness. So we do not have any kind of force or weight when we are, like, if anybody will cut that string, if anybody like, or the string will fails, that like the string will breaks, then the entire lift along with the body is in free fall. So by the time, so you can see that now there is no contact at all. N is equals to 0 means there is no contact at all, because basically this entire lift forces, everything going up or coming down, acting when they are actually a contact forces. So if the N is 0 means there is no contact force at all. Clear everybody? Understand all of you? Yes. So that is what. So now for example, if you have taken, so let me consider, so this is what about, so N is equals to 0 means in the sense of contact is just about to end. Okay, all of you. So about to end means in the sense of the wire is ready to break. So as soon as the wire will ready to break, at that moment, N will become what? Normal reaction will become 0. So that is the meaning of N is equals to 0. So when the wire breaks or string will breaks, N equals to 0 means they lost the contact. Contact has been gone. So that is what you have to remember it. Now, so there is a case again. So next case again consider. So if you observe inside here, so what will happen means, so there is a man. So we all knows that inside the lift. Now we know that two forces are acting. One is normal reaction, upward direction, and another one is acting downward direction. What is that, everybody? Which is equals to weight, mg. Clear? And as we know here, if, for example, acceleration is equals to 2g. If A is greater than g. Do you understand, everybody? A is greater than, what is that? Acceleration of the lift is greater than g, means let the A is equals to 2g. So in this case, observe very carefully. So if I draw the FBD, one is normal reaction, downward it is acting mg, and what is the acceleration now? A equals to, A is equals to, how much is the acceleration? 2g. Am I right or wrong? That is what. So if you observe in this case, so mg minus n, this is positive and this is negative as it acceleration downwards. Yes or no? So mg minus is equals to, so we all knows that mass is equals to, so mg. So sorry, F net is equals to ma. So F net is equals to ma. So we all knows that here. So m into 2g. So that is what, A is equals to 2g. Am I right or wrong, everyone? Please respond. All of you?
Yes, sir.
Yes. So which will turns into, so mg minus n, which is equals to 2mg. 2mg. So n is equals to, what will happen? mg minus 2mg. So n is equals to what, everybody? N is equals to minus mg. Am I right or wrong? So
Minus.
n is basically negative. So why I taught you this one? Keep it in mind. Normal reaction negative, it will not at all possible at all. So that is why the acceleration in downward direction, it is not possible to greater than what? Not possible to greater than, all of you? Greater than
G.
acceleration due to gravity. Why means n is equals to 0 itself. If n is negative, we all knows that n never be less than 0, because at n is equals to 0 itself, what will happen? Already the body lost what? Almost the contact is about to end. So if it is n is equals to negative, means it is less than 0 or greater than 0? Less than 0. Understanding? Negative means it is a less than 0. Means in the sense of what? There is no contact at all. So if there is no contact at all means, then what is the normal? N is equals to 0. It is not at all existed. So it is not at all possible, because for n is equals to 0 itself, what is happening? Almost contact is just about to end. So n is already not existed when the contact loss. Then here the acceleration of the body is 2g, means n value will come negative, which is basically impossible in the real life situation. So this is what about a lift problem when the lift is in freely fall. Suppose the wire will string, the string of a lift will breaks or the wire will damage. This is what the case it will be happening. Do you all understand, all of you? Everybody? So by that time, what is the normal reaction? N is equals to 0.
Zero.
Okay? Please, that is what you have to remember it. So please solve it. Clear, everybody? Understand, Mr. Narayan?
Yes, sir.
Murali? Mr. Rishi? Yeah. So please solve it. So this is what about it. Now, the same thing we'll consider like a lift again. So all of you observe very carefully. Lift is like one chain is going up and another chain is coming down. So let me consider. So again, I'm considering a lift problem. So all of you observe. So this will be, everything is important. Lift problems are very, very important actually. So there is a pulley. Actually, if you notice it, lift up, there is a pulleys actually. So pulleys only. So we are having a rope which is attached to the lift one side. So let me consider. And there is a man inside the lift. So like you can consider. So there is a rope which is actually the hold by the man. Let me consider like this. Okay. So now as it is both are same string, so that the tension in the both the strings is same or different. Everybody. The tension in the both the strings are what? Same. Am I right or wrong? All of you? Yes? Please respond. Yeah. So
Yes,
now
sir.
here, if you notice it, as the lift is going down, so the force is exerting downwards or upwards? Like you
No.
must downward direction. Clear? So downward direction. So let me consider now the mass of the person is 60 kg. So what is the mass of the person, everybody? 60 kg. And let me consider the lift mass. The mass of the lift mass, which is equals to small m, I'm considering, which is equals to 30 kg. How much lift mass, everybody? Lift mass is 30 kg and the person's mass is 60 kg. Okay. Now, find the force exerted on lift. They're asking, calculate or find the force exerted on lift by man. Okay. So imagine this entire system is like a equilibrium system. Okay. So equilibrium system, it is considered as a equilibrium system. So now they are asking, so find the force exerted on lift by a man. That is what? Weight of a man. Okay. So force means what? Weight of a man. Am I right or wrong, everybody? Man, as shown by weighing machine. As shown by weighing machine. So a man is living inside, standing inside the lift. What is the force exerted by the man on this lift? That is what they are asking. Okay. So let us observe very carefully. So this is what the question they have given. Now how to find it? How much is the force it is exerting? The force exerted on the lift by the man. That is what we have to find it. So observe very carefully now. So there is a person who is standing inside the lift. Let me consider. So his weight is acting downward direction. So as we consider, his weight is how many kgs, everybody? 60 kg. So that what is the weight acting downward direction, everyone? Yes, please. 60 G. Okay. Now there is a force which is acting upward direction. That is what? N. And along with the N, some other force is also acting. String it is. So string means who is acting? Everybody.
Tension.
Means all of you. Tension. So that is what. So from this I can say something. So as we all knows that, all of you observe very carefully. So this both forces is equals to this force. So what is that? T plus N is equals to how much, Ra? T plus N is equals to, all of you, 60 grams. Clear, everybody? Yes, please. All of you. These two forces is equals to this force. So T plus N is equals to 60 grams. Now, sorry, 60 G, not grams. Now, as we know, the tension of the body is exerting upward and the man is exerting force in the downward direction. Then T is equals to what? T is equals to string. Inside the string, T is equals to what will happen? If you consider the string, the tension is acting upward direction, force is acting downward direction. So from the T is equals to what will become? All of you. T is equals to F in the string. Okay. That is what. Now, consider lift. Forget about the man. If you consider the lift, what is the mass of the lift, everybody? Mass of the lift is what? Yes. Mass of the lift is what, Ra? 30 gram, 30 kilogram. Yes or no? So 30 G. So if I consider the lift, all of you observe very carefully. So let me consider this is the lift. So we all knows that. If the lift is exerting, so two surfaces are in contact. So this is the man, like we have studied. So suppose this surface is exerting a normal reaction on this object is N means, then this object is also exert normal reaction on this surface. That is what we used to call as, that is also N. Am I right or wrong? Please understand, everybody. You studied or not? Like that, a man is standing inside the lift. Now the lift is exerting a normal reaction on the man is N. We have already done. Now the man is also exerting the same normal reaction on the lift. So that normal reaction will act downward direction, upward direction. Everybody. That the normal reaction will act in the, yes, please. Downward direction or upward direction? Downward direction. Okay. Upward, it is only tension in the string is acting, and downwards, as it is 30 kilograms, so that it is 30 G. 30 G means what? W is equals to mg. Am I right or wrong? Everybody, all of you. And the normal reaction exerted by the person on the lift is also exerting in the downward direction. So from this I can say, can you tell me tension T is equals to what will happen? N plus 30 G. Am I right or wrong? All of you? Yes? Please respond. So if there is a lift, all of you remember, lift is actually a surface. So the lift exerting, the normal reaction exerted by the lift on the person is upward direction N. Then the normal reaction exerted by the person on the lift is downward direction. That is what N. We all studied or not surfaces, everyone? Like objects. Yes?
Yes, sir.
So this one is exerting N reaction, means this is also will exert N reaction. If any third body is there, this one is N dash, means this one is also N dash. Same like here. So we are having two equations now. What is the two equations, everybody? First one is T plus N is equals to 60 G. And now I will take it as a N is come this side. So what will happen? T minus N is equals to 30 G. So add both the equations. So if I'll add both the equations, N will get cancelled. So T plus T 2T is equals to 60 plus 30, which is equals to 90 G. So T is equals to how much, guys? Tension in the string is equals to how much it is? 90 by 20 G. So which is equals to how much, Ra? 45 G. Okay. So that is what T. Now I want to find normal reaction. That is what? Find the force exerted on lift by man. What is the force it is exerting by lift by man? Everybody, lift by man. Understanding what is the force it is? What is the force it is actually? The force exerted by exerted on lift by man. What is that force? Normal. Right or wrong? That's all. So we have to find that one. So what is that? T minus N is equals to 30 G. So now T is equals to 45. N is equals to 30 G. So N will come this side, it will go this one. So what will happen? N is equals to 30 will come this side. So 30 G, let it be. So what is the answer will come? If I take
45 minus 30.
Yeah, 45 minus 30 G. So forget about the G. G value, we all knows that. So N is equals to how much it will come? All of you.
G.
This is 45 G, correct? It is not 45 G. So N is equals to how much, Ra?
15 G.
15 G. Okay. So that is what. So this is the force exerted by whom, guys? Everyone? That is the force exerted by person on the lift. Clear, everyone? So the person. Okay. Find the force exerted on lift by man, they are asking. So what is that force? The force exerted by a man on the lift is what? What we consider? The force. This is the surface, means lift will exert normal force on the man, that is N. Then the man also will exert force on the lift, that is also equals to N. Is it clear, everyone? Understand or not?
Yes, sir.
Yes, that is what. So N is equals to how much is the answer? N is equals to
15 G.
Okay. So that is the force exerted on lift by a man. That is what you have to remember. Anybody having any doubt? You can ask. Clear, everybody? Yes?
Yes, sir.
Yeah. So this is what about Newton's
Yes,
third
sir.
and as well as lift problems. So you have to be very careful. If you solve plenty of sums, then only your fastness and as well as understanding the question, the capacity of understanding the question will develop. Only will solve plenty of sums. So I already started coming to know many of you are not focusing full-fledged. So fully going diversion. You have to balance everything. How you balance the class, same way you have to balance it. By the time even we are studying more subjects, you have now even less subjects. So kindly focus it. So the next concept which we are going to study, which is we already studied in class 9th. So same concept, similar it will be there. So that is what? Conservation of momentum. So conservation of momentum means, like forget about the momentum. Like ninth class, we'll study conservation of mass or conservation of energy. So remember what is the conservation of energy? Everybody, even ninth class I taught you, conservation of energy or mass or whatever it is. Mass neither be created nor be destroyed. Or energy means energy neither be created nor be destroyed. Now, same way conservation of momentum means in ninth class you might be studied. So momentum means we already know the formula. We studied Newton's second law. What is the momentum formula? Everybody, P is equals to fastly mass into velocity. So that is what momentum we studied. So conservation of momentum means, so we can say like generally like ninth class, momentum before collision is equals to what, everybody? Momentum
After collision.
momentum after collision. So that is only the thing which we studied in the ninth class. Now, if I do the subtraction and equals to 0, that is what? Total momentum before collision, initially minus momentum after collision, which is equals to how much it will come? Which is equals to
0.
0. Means in the sense of what? The net external forces which is exerting on the body is always remains 0. So that is only the conservation of momentum. So according to the Newton's second law, all of you observe, according to the Newton's second law, so what is the Newton's second law? F net is equals to change in delta P divided by delta T. So this is what we have developed a formula for one system. If I consider entire particles in the body, consider as a system, then we have found that F net is equals to delta P, change in momentum divided by change in time period. Am I right or wrong, everybody? Yes. So as we know that initial momentum is equals to final momentum. That is what momentum before collision equals to momentum after collision. So if I do initial momentum minus final momentum, what is the finally change in momentum? The resultant momentum is how much? Which is equals to, everybody? Yes, please.
0.
0. So means in the sense of, that is what, if I consider as an entire system, the F net, the net external force is equals to how much, guys? Everybody? Net external force is equals to 0. Understand? So why net external force is 0? So we all knows that rate of change of momentum only force. Am I right or wrong? All of you. Rate of change of momentum. Rate of change of momentum is only called as what? Everybody. We used to call it as force. Clear? So if the entire momentum is 0, means what is the net acceleration? Sorry, net external force is equals to what? Net external force is 0 when change in momentum is equals to how much? Change in momentum is equals to 0. Means momentum neither be created nor be destroyed. Before collision and after collision, change in momentum is equals to how much, guys? Everybody. Change in momentum is equals to 0. That is what you should understand. So, if I take change in momentum is equals to 0, for what actually? For a system. Do you all understand it? For a system, means in the sense of P is, that is what? P means what, guys? P, what do you mean by P, everybody? P means what? Momentum. So momentum is always remains constant. That is the meaning of it. Am I right or wrong, everybody? So change in momentum is 0 means what? Momentum is remains constant. That is the meaning of that. Am I right or wrong, everybody? Yes? All of you. So delta means change in momentum. So momentum, the change in momentum is 0 means the P of the body is remains constant or varies. P of the bodies remains constant. Clear? That is what. So I am not considering individual body. For example, two bodies are colliding. So I am considering entire system. So entire thing we used to call it as what? Everybody. Entire thing we used to consider as a system. Clear, everyone? So systems external force, that is what? F net. The external force is equals to 0 when change in momentum is 0. So change in momentum is 0 means, if I consider basically like in physics, we'll use a word called as isolated system. Like it is not at all experiencing by any other external force, means in the sense of F net is equals to how much, guys? No, the sum of the external forces is equals to 0. Means what is the resultant force? Everyone. The total resultant force is equals to what? 0. Clear, everybody? So that is only we used to call as law of conservation of momentum. So means F net is equals to the external force exerting on a system is always equals to 0. That is only called as conservation of momentum. Means momentum before collision is equals to momentum after collision. If I do that, what is the change in momentum, everybody? What is the difference? No
Zero.
change in momentum.
Zero.
So P is always
Zero.
remains constant, or where is that? P is always
Constant.
remains
Constant.
constant. That constant only we used to called as, what is the word we can use it? Yes, please. Conserved. Understand? Always remains conserved or constant. That is what you should understand. Everybody understand or not? All of you? Clear?
Yes, sir.
That is. So now let us solve the example. So ninth class, if you go to the ninth class, you might be solved the gun and bullet questions. Do you remember, everyone? All of you?
Yes, sir.
Gun questions. So as we know, for example, if I consider there is a gun, so which has been fired a bullet. So now the gun is exerting a force on whom, guys? Actually, now there is a bullet which is fired by the gun. So now you tell me, now bullet is exerting force on what direction? Everybody, forward direction. Am I right or wrong? All of you? So let me take, this is the
Yes, sir.
bullet.
Gun
This is
is
the gun.
at
Okay.
that direction.
Now we know that the force exerted on bullet by the gun is in forward direction. Then the bullet also, because we all knows that Newton's third law, every action there is an equal and opposite reaction.
Opposite
Right or
reaction.
wrong? That is what. So if the gun is exerting some kind of velocity on the bullet, so then the bullet will move forward direction. Then bullet also will exert same force on the gun, so that gun also will give you the backside. That is what backside movement. That is what we used to say like jerk.
Advantage.
Okay. Yeah, jerk we say, which is called as recoil velocity. What we used to call? We used to call as recoil velocity. So this is what actually the force exerted on bullet by the gun is forward. Then the force exerted by bullet on the gun is what? Which will act on the backward direction. Clear, everybody? Yes or no? Now, I want to consider entire system. What is my entire system, everyone? Bullet plus gun, both are called as what? Bullet plus gun, both are called as my entire system. Yes or no? So gun plus bullet equals to, I am considering as a whole system. So if it is a whole system, means what is the net external force, everybody? Net external force is equals to how much, everyone?
Zero.
Zero. So clear? That is what. So means in the sense of what? F net is equals to 0 means, so action is equals to, we all knows that. So what is the F net? Two forces are acting on this body. F net is equals to 0. What is the two forces here? One is forward force, another one is what? Backward force. That is what?
Backward
velocity. So I will write it. So the sum of the F next external is equals to the force exerted on bullet by the gun plus the force exerted by the gun on bullet, by the bullet on the gun, which is equals to what, everyone? Which is equals to 0. So why means we all knows that if the force exerted by the gun on bullet is equals to minus force exerted by bullet on gun, both are minus. Am I right or wrong, everyone? All of you? Action is equals to what? This is action and this is a what, everyone?
equal and opposite.
This is the reaction. So every action there is an equal and opposite reaction. If I bring this minus FGB this side, the force exerted on gun by bullet, which is total is equals to how much? Total is equals to how much, Ra? 0. That is what you should understand it. So means in the sense of what? Initial momentum Pi is equals to Pf. The initial momentum is equals to final momentum. Yes or no, guys? Because this is the initial move. That is what we can say. Momentum of the gun, which is equals to momentum of the bullet. That is what we used to understand. But one is action, another one is what? One is action, another one is what, guys? Another one is reaction. Clear? Now let us take it for example. How it will come. So let us see. What is the initial momentum of the gun? Gun is at rest. It is not fired. So what is the initial momentum? It is rest means P is equals to M into V.
Yeah.
So no velocity. Velocity is 0 means what is the initial velocity? Sorry, initial momentum.
0.
0. Okay. So remember, only momentum possessed by the bodies who is in motion or who is in rest, everyone. The only momentum is possessed by only in what? By virtue of its motion. So the objects which are in motion only, they will possess the what? Everyone? Momentum. So the objects which are in state of rest, what is their momentum, everybody?
0.
Momentum is equals to 0. That is what you have to remember it. Now, so we all knows that P initial momentum is equals to 0, which is equals to what is the final momentum? Final momentum means two moments. What is that? Momentum of bullet plus momentum of gun, because I consider both is equals to single system. So momentum of
Yes,
gun
sir.
plus momentum of what? Momentum of gun plus momentum of bullet.
Bullet.
So equals to 0. So from that I will write it. What I can write? Momentum of gun is equals to, this plus will come this side. What will become? Minus momentum of bullet. Is it okay, everyone? All of you?
Yes, sir.
Yes. So that is what you have to remember. So always momentum is remains conserved, remains constant. That is what is conservation of momentum. Movement P is always remains constant or conserved. That is what you should understand. Is it okay, everybody? Clear? All of you?
Yes, sir.
Yes. Now let us solve with this one question. For example, there is a gun. There is a gun. Okay. So now you can see a bullet is fired from the gun. Okay. So now if you have noticed it, the mass of the gun is 5 kg. The mass of the bullet is 0.2 kg. And velocity of the bullet is 200 meter per second. And velocity of the bullet, that is what we used to say, what velocity? Recoil velocity. Okay. Recoil velocity U is equals to how much they are asking. So what is the answer, everyone? Very simple. Initial momentum is equals to final momentum. What is the initial momentum before firing? 0. Final momentum means what? Momentum of gun. Okay, sorry. Whatever it is, you can take it. So momentum of gun, okay, minus momentum of bullet. So from that I will say momentum of bullet is equals to momentum of gun. So velocity, recoil velocity of the gun is equals to mv by u. Mv by m. Am I right or wrong, everyone? Yes,
Yes,
or
sir.
no? Yes. So this is actually capital M. Okay, because mass of gun it is. So mass of gun. So what is happening? Small m is equals to 0.2. Velocity is equals to 200 divided by capital M is equals to how much? 5. So which is equals to 200 into 2, which is equals to 40. So 5 ones are 5 eights are. So how much is the recoil velocity, everybody? The recoil velocity of the gun is how much? Yes, please. Recoil velocity of the gun is equals to how much, Ra? 8 meter per second. That is what. So if the gun will move with a 200 meter per second forward direction, then the gun will hit backward with what speed? Everybody. 8 meter per second. That is what you have to remember. Is it okay, guys? Everybody clear? Yes? All of you?
Yes.
Yes. So that is what you should understand. Okay, Mr. Rudreswar?
Yes, sir.
Yeah. So now, then there is another question. So let us solve this question also. Then all of you observe very carefully. So there is a 1 kg object which is traveling with the 2 meter per second. Which is traveling with what meter per second, everyone? 2 meter per second. In the same direction, another body, there is a body 2 kg which is traveling with the 1 meter per second. Now you tell me who is traveling the faster, 1 kg body or 2 kg body? Yes, please. 1 kg body. So that after a certain time, definitely the 1 kg body will hit or not the 2 kg body, everybody. Yes. So after collision takes place. So after collision, definitely there is a exchange in momentum. Am I right? Will you all agree with me? After collision, there is
Yes,
a momentum. So after collision, the 1 kg body is traveling with the 1 meter per second. Then 2 kg body will travel with the dash speed. Don't take 1 meter. That is wrong. Sorry. It is 1 means it is 2 means. So we have to find it according to the formula. So what is the velocity after collision? That is what they're asking. So if you consider this entire as a system, so if it is a system means F net is equals to what? Everybody. F net is equals to net external force. External force is equals to how much? Net external force is equals to fast Dira. Yes, please. 0. Clear? So means in the sense of what? P is always remains constant, or P is equals to what, everybody? P is
Constant.
okay. So that is what. So now we all people knows that. Again the same thing here. So initial momentum is equals to final momentum. So what is the initial momentum? Everybody check it here. What is the initial momentum? Mass of the bullet. That is, you check it here. Mass of the body into velocity of the body plus mass of the body into velocity of the body. That's all. So what is the answer? Mass of the body 1 into velocity of the body 2 plus mass of the body is into velocity of the body, which is equals to after collision. After collision, what is the velocity? 1 kg, 1 meter per second. 2 kg, how much we don't know. Let me consider that is a V. How much it is? All of you? V. Okay, wow. All of you understand how? So what will happen? Momentum after collision. Momentum after collision equals to 1 into 1 plus 2 into velocity, I don't know, which is equals to V. That's all. So 1 into 2, 2 plus 2, which is equals to 1 plus 2 into V. So 2 2s are what? 2 plus 2, 4. So 4 minus 1 is equals to TV. So V is equals to 3 by 2, which is equals to how much meter per second? All of you. V is equals to 1.5 meter per second. So after collision, this body is traveling with what velocity, everybody? Traveling with a 1.5 meter per second. But if I calculate the total momentum before collision and total momentum after collision, the momentum is remains always what? The momentum of the body is always remains constant. Clear? That is what we called as conservation of momentum. Okay. So there is one more question. You solve this question. After solving that question, I will wind up the meeting. So there is one bomb blasting question. So let us discuss that. All of you finish this question. Till here, any doubt? Mr. Monish, Mr. Narayan, do you understand? Ishali, Manya and Samya?
Yes, sir.
That is. So very, very important. Conservation of momentum. So one bomb question, last question, finish the meeting and join back and we'll finish that. Okay.